Major support for Do the Math has been provided by Chevron, Edison International, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Cece.
I'm Shourya. For math homework help, call in Bakersfield 636-4357. Everywhere else, 866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net and on social media.
Well, Shourya, thank you for taking care of that. Now Cece and I don't have to do that.
That's
so
right.
You're
nice
welcome.
job. So where do you go to school, Shourya?
Ronald Reagan,
And what grade are you in?
the 4th.
How is the 4th grade?
I'd say it's pretty good.
It's pretty good. Do you go to school longer now than you did last year?
By 10 minutes, yeah?
By 10 minutes, yeah. See, that's why I think it was new this year because of the busing and things like that. It used to be where you have to go to school 30 minutes longer, and now you only go 10 minutes longer.
Yeah.
Is that because you're smarter now in 4th grade? You don't need as much time as the 30 minutes? You only need 10 minutes more?
I really do not know.
Are you cool with it, though?
Yeah, I guess.
Yeah, all right, why not, right? So what is one of the things that you most like about 4th grade so far? Because you've gotten through 1/4 of it, correct?
Yes.
So what is one thing that you really like about 4th grade?
Math?
You just saying that because you're on Do the Math?
No.
Because if we were doing the English, you would say reading and English, maybe? No. Okay, so you do like the math. What kind of math things have you been working on this year?
We've just been working on, like, I guess the order of operations right now.
Okay, so you like order of operations.
Yeah.
And you know that.
Yeah.
And is there anything that you've done this year that you think was a little difficult and you maybe could have spent a little more time on it?
I don't really know.
Everything's been going pretty smoothly so far then?
Yeah.
All right, good. Are you ready to help me with our social media problem of the day?
Probably.
All right, that's the answer I wanted. Let's take a look at it right now up on the screen. So it says, what is the pattern? So we have a couple of numbers up there. So Shourya, when you look at that, what is the first thing you notice? What do you think of when you look at that?
They all end in 6s.
Most of them end in
Yeah.
6, except for the
Most.
first one. That's a good observation, right?
Yeah.
So they're asking what the pattern is, because in mathematics, it's all patterns.
Yeah.
We just have to find the pattern.
Okay.
And as you get older and get involved in more higher level mathematics, the patterns become a little more difficult, let's say. So now all we have to do is find this pattern. So what do you think the pattern could be?
Multiply by 6.
Multiply by 6. Is there anything else it could possibly be?
I don't think so.
All right, well, why do you say multiply by 6?
Because 1 times 6 is 6. 6 times 6 is 36. And 36 is, what I'm guessing, is 216.
So 36 times 6, you're guessing is 216?
Yeah, I'm sure.
You're sure of it?
Yeah.
All right. So if we had 6, and then we said, do you know what exponents are?
Yes.
Can you explain what an exponent is?
Exponents are basically kind of like repeated multiplication.
Good. So can you give me an example? Maybe use 6?
6 squared would be 36 because you're multiplying 6 by 6.
Right. So we're going 6 times 6, right?
Yes.
So the pattern you had was multiplying by 6. So we start at 1 times 6, we get 6.
Yeah.
Multiply it again. So what do you think 6 to the 3rd power, 6 cubed is?
216.
216, right? Okay. So we had add 6, add 30, multiply 6, and multiply 5. So your final answer on this is going to be what?
Multiply by 6.
Multiply by 6. So you're saying C is the correct answer?
Yes.
All right, let's find out. There you go. C is the correct answer, dude. Nicely done. See, that problem wasn't so hard, was it?
Yeah.
And you even knew exponents. All right. 636-4357 is the phone number. We do have phone tutors available most Tuesdays and Wednesdays throughout most of the school year between 3:30 and 5:30. Time now for today's Math in the News. And today's Math in the News has to deal with a young student that did something pretty extraordinary. And this is, if you're into science, this is the thing you want to be checking out once you're in junior high and high school. The 3M Young Scientist Challenge. So what they do is they present challenges for students, and there's cash involved, which struck my eye when I saw this. So let's go ahead and take a look at what was going on. So Discovery Education and 3M, they partnered up, and what you do as a student is you send in a short video, 1 to 2 minute video, explaining what you're going to be talking about. Then, if you happen to be selected, and there are 9 of the other winners down here along with the student that we're going to be featuring today, you win yourself $25,000, a mentorship with a scientist from 3M. So you can see the different students here and some of the projects that they're working on. So let's go to the boy that we're going to be concentrating on today. All right, Suresh, and what he did is the project, the way he came about this was, he was getting produce, and there were things in his yard, or they would just bring things home from the store, and fruits and vegetables, and he knew that there were pesticides on these plants, these vegetables that you're bringing home. Even though people say that these are being washed, or you even wash them yourself when you bring them into the house, he wanted to know if there was any pesticide residue left on this produce once it was brought into the house. So he developed this process of finding out how you can determine if there is still pesticide residue left on this piece of produce, whatever it is. So he's using spectrophotometry. So it's using wavelengths to figure out the amount of residue from the pesticide that is still on there. What they needed was a 85% accuracy rate, and he was able to get 93% accuracy on the pestiscan that he developed. So it's a short little video that you put together. It takes a little while to get everything together and get it going, but the video portion of it is pretty short. But the kid got himself $25,000, going to be working exclusively with a 3M scientist, and the caricature, I'm not really sure which one of those guys made it. I doubt either one of them did, but they do. It's a little something at the end of that right there. But if you're into science and you've got yourself a curious little idea, you want to try something out, there are amazing things that happen when you just take an everyday problem or something that you're curious about and want to see how can you solve that, or how can you make something that is already out there a little bit better, make it more efficient. That's today's Math in the News. Oh, you know what? I was almost forgetting. We do have a problem to do with this. That's almost today's Math in the News. So, change in formula, percent change, right? So, the difference in the two amounts. So, because he needed an 85% accuracy rate, he got 93%. So, there is a difference in percent. So instead of using 93 and 85, we're going to use some simpler numbers. So we're going to take the difference in the two amounts. So let's say our original amount was $20 and our new amount is $25. So the difference in the two amounts is $5. We're going to divide that by the original amount. The original amount was $20. So if we have 5 over 20, we divide that, but we can simplify that right now as 1/4. 1/4 turned into a decimal is 0.25. We take that, we multiply it by 100 because we want to get the percent difference. When you're multiplying by 100, you can simply move the decimal 2 places, and we can see that that would be a 25% difference in the two amounts. So if it went from $20 to $25, it increased by 25%. One way that you can check this also is you can go, all right, $5 is what part of 20? Well, how many 5s will go into 20? 4, which is 1/4, 25%, and now that is today's Math in the News. We'll be back with more right after this.
All right, everybody, welcome back. Today we're going to play with some fractions to see how we can use our understanding of mathematical multiplication facts to find some more extravagant multiplication facts here in the classroom. So if we use the understanding that 7 times 4 equals 28, I want to multiply something to make 29, and I want to use a 7 to do so. but we're running into some problems. 7 times nothing makes 29 as a whole number, so we have to get creative. Let's think about our understanding of fractions. 4 of what will give me a whole? Because I only need one more whole for 28 to become 29. I only need one whole piece or number or unit to increase from 28 to 29. So what 4 of something gives me a whole? Well, if we think about a dollar, 4 quarters makes a dollar, and a quarter is worth 1/4 of a dollar. So if I have 1/4, times it by 4, we'll see what we get. Reminder, we can take the whole number 4, make it a fraction, 4 over 1. 1 times 4 equals 4. 4 times 1 makes 4. Hey, lo and behold, this equals a whole. Well, how do we use this into our math? Well, we're still going to multiply by 4 again. But to get this extra unit, I need 1/4. So it's no longer 7 times 4, it's now 7 and 1/4. And we can check that math really quickly, eliminate our work here, double check our math. So 7 times 4 does give us 28. Now we're going to use the 1/4 times 4. We'll turn 4 into 4 over 1 for multiplication's sake. We get 4 over 4. Simplifies down to 1 whole. We combine 1 and 28. We get 29. Boom, it works. But Mickey, what if we want to get to 30 or 31? Well, let's try that out. So now instead of 28, and we're not going to 29, let's shoot for 31. 7 times 4, somehow we can make 31. Okay, so we use our power and we think, okay, 7 times 4 we know makes 28. Well, from 28 to 31, same experience we used before. We'll get some area here to work it out. Again, in our head we know 7 times 4 is 28, but now I want to be 3 times as large. Well, before when I only needed one more unit, I used 1 over 4. If I need 3 more, well, 1 was 1/4, 3, I sense a pattern here. Sounds like instead of 1/4, I'm going to use 3/4. Multiply by 4, our goal is to get 3 whole units in addition. Let's try it out and double check. 4 becomes 4 over 1 for the sake of multiplying fractions. 3 times 4 is 12, 4 times 1 is 4. We can reduce 12 divided by 4 gives us the 3 that we're looking for to increase in value. So instead of 7 and 1/4 to give us an additional 1 unit, now we're going to use 7 and 3/4 to give us the additional 3 units. Let's multiply it out and double check. 7 by 4 again is 28 like we saw before. Now I have 3/4 times 4. 4 becomes a 4 over 1 like we just saw. 12 over 4 becomes 3. Hey, 28 and the 3, we get 31. Now they match. So we're noticing some patterns here in fraction work and multiplication. So it's a lot of different ways we can get it. One last example, 8 to become a 57. Students will say, well, 8 times 7 is 56. That's really close. Now if we speed it up a little bit, I know I need 1 additional unit. Well, what times 7 is going to give me an additional unit? 1/7. 7 in the 7th, you're going to get 1 whole unit. So I make this become 8 and 1/7 times 7, 57. Again, 8 times 7 is 56. If I get 7/7, that's a whole, give me 57. So if you're ever wondering, oh my gosh, I have this number, how do I work it? Think about your closest math fact and use your understanding of fractions to close the gap, find that whole unit, and get you all the way to the end. Enjoy, use those fractions, and have fun doing your math.
And thanks to Mick for that. In studio, we have Shourya, a 4th grade student from Reagan Elementary. And other than dividing right now, what is something that you're going to be doing in class? Have you taken a look inside your math book to see kind of stuff that's coming up?
Basically, a math book is just one chapter instead of like all the chapters in like one book.
Oh, so you just get one part at a time?
Yeah.
Okay, and you said that you've been pretty proficient in working well with the order of operations, correct?
Yeah.
All right, well, first of all, we're going to have you and Cece work on some division problems with the remainders, all right?
Okay.
Head on over to the board, young man. All right, Cece, I'd like you to come up with a 4-digit number And then Shourya is going to come up with a 2-digit number to divide into that.
Fantastic. So let's go with 2, a 1, a 5, and let's go with a 3. So go ahead and tell me what you know what, I kind of put that up kind of high, huh?
Yeah.
I did.
I was going to say, you get.
I kind of got a little carried away on that one. Let's go ahead and let's go ahead and do that a little better for you. Okay, now what 2-digit number would you like?
Let's do 19.
19. I like it. All right, now I'm going to go ahead and I'm going to change the color for you. I'm going to give you a blue color. You good with that?
Sure.
Fabulous. Okay, now take it away. Tell me what you're doing when you do it.
Okay, first you divide the 19 into the 2, but 19 is way bigger than 2, so the 1 comes into the party, which makes 21.
I love that.
19 can go into 21 one time.
One time. And we're having a party now.
So now you subtract 19 from the 21
Okay, tell me how you got that why are you bringing the 19 over there?
because you multiply. Because since 19 can go into 21 one time, you have to subtract 19 from 21.
Okay, so you did what a lot of kids would say, they're multiplying 1 times the 19 and you get that. Perfect. Okay, great. Continue.
21 minus 9 is 2.
Good.
So then you drop this 5 down, which would make 25.
Fabulous.
19 can go into 25, which would be another 1,
Perfect.
which means you do the same thing
Good.
on here, which would mean it is that you get 6.
Okay.
Then you drop down this 3 over
Okay.
here, which gives 63.
Now, I know a lot of kids would say 1963. I don't know. How do we kind of maybe start to think about how many times that's going to go in?
Well, you'd, whichever answer is the closest, but not bigger than 63,
Okay.
that is the number that you would be using.
Okay, so do we want to guess an 8?
Nah,
Tell me why.
because that would be way too big.
How do you know?
Because 19 times 8, let's do it here.
Do you need to? Do you need to know for sure when you're doing a guess, kind of like that?
You just go with an answer, and if it's like too big or too small,
Okay.
you think you add one more.
Okay, so
or you
I'm
go
gonna
smaller.
back up and let you keep going. Tell me about your 19 and your 63. What do you think you're gonna pick?
So I think I'm gonna pick 3.
Why?
Because I think if I picked 4, it would be a little bit too small.
The 4 would
Well,
be 2.
I meant too big.
Okay, so when you look at the 19, do you kind of round it to a number?
Yeah.
What do you think of?
I round it to a 20.
Okay, so if you round that to a 20, what are you thinking about that one?
This would be a 60. which
So
goes
that's
in
why you're
25.
picking a 3. Ah, I like it. Okay, so let's see your 3. Let's see what
19
happens.
times 3, 7. So then you, 57. That's
Okay.
very close to 63.
It is pretty close. Okay, so let's keep going. Oh, yeah, don't forget your 3 up there.
So then you put the 3 up here.
Nice.
Then you subtract 57,
Okay.
which is 13, which gives you a remainder of 6.
Nice.
But there's nothing to drop down, so
Okay.
you'd make this as a remainder.
Okay. So that's what we have left over when we do our divisions,
Yes.
that remainder of 6. That's what a remainder means?
Yes.
Awesome. I
Good.
like it.
Nice problem right there. So,
like it.
Cece, maybe go over with Shourya. How do you know that that is the correct answer? Is there a way to check your answer?
Oh, that's a good. Do you know how to check this answer?
I don't know.
Okay, that's okay. So I want you to think about this. So if I'm doing 6 divided by 2, what's my answer?
3.
Okay. What's the relationship between 2 and 3 that gives me back to 6?
2 times 3 equals 6.
Ah, good. Okay, so I know then that I should be able to do some multiplication to get back to this, right?
Yes.
So do you know what I'm going to multiply?
113 by 9.
I am. So so let's hold this off to the side, and we're just going to do the 113 times 19 and show me what you get.
Okay. So
Okay, so you're just going ahead and doing that, and then now you're going to add. Okay, so we're at 2, and let's go ahead and fix that, make that more of a 4. So we've got 2,000.
What?
There you go. 2,147. Was that what we were supposed to get?
No.
I was supposed to get this, right? So are we wrong?
But we're supposed to add the remainder.
Ah, good. We need to add it. We don't multiply it?
No.
No, we just add it. You're exactly right. So go ahead and finish adding that.
Wait, 1, 2.
And we're back to our answer. Nicely done. That's awesome.
There you go. Now you learned how to check your problem when you're doing those division problems. For a great problem right there and checking at the same time, you've got yourself a ticket to go see the Bakersfield Condors. So congratulations on that. Season just getting started, so hopefully you have an opportunity to go check out the Condors this year. We'll be back with more right after this.
Is there water on the moon? Actually, yes, but not like we experience here on Earth. On the moon, water is found all over the surface, but it's mainly in the form of ice and not pools of liquid water. Some places have more water than others. At the poles of the moon are areas that never receive any sunlight, and so they're extremely cold. We call these permanently shadowed regions, and there could be a lot of ice inside them. The ice inside these regions may be mixed in with the lunar soil, buried deep below the surface, or it could be a sheet of ice. Outside these extremely cold places is much less water, but it's still there. Surfaces on the moon that do see sunlight experience extreme temperature changes of 300 Celsius. This makes it hard for water to survive on the sunlit moon, but the water that does survive is unlike any water we experience here on Earth. But what does that mean? Imagine you have a handful of sand, and you spread the grains of sand out so far that no grain touches another grain. An individual grain of sand represents a single molecule of water. And this is what we observe on the sunlit surface of the moon. The sunlit moon, however, has 100 times less water than the Sahara Desert, but the poles of the moon may contain tons of ice. So, is there water on the moon? Yes. And one day, future astronauts may be able to harvest this water and use it for drinkable water, breathable oxygen, or rocket fuel to take us farther out into our solar system.
All right, in studio, we are honored to have Curtis from Hathaway with us today. How are you?
I'm doing good. How are you?
Excellent, thank you. So, Curtis, what is your role at Hathaway?
My title is I'm the Chief Operating Officer for Hathaway. We're a small independent oil and gas producer.
Okay, good. I was going to say, because a lot of kids out there may not know what Hathaway is, but we all know it's involved with oil.
Yes.
And how long have you been with the company?
Just over 8 years.
Okay, and how did you get started? I mean, were you always in this industry, oil, or was it something that you kind of fell into?
Originally, I went to college in Michigan. I got my degree in mathematics. I worked in the automotive industry for 2.5, 3 years. Before I went to school in Michigan, I played football at BC. I'm a Bakersfield boy.
Okay.
And my kicking coach at BC was Chad Hathaway, the owner of Hathaway LLC.
Oh, right, yeah.
And 2 years into my career, I was talking with him, and I didn't really like the corporate organization, didn't really like the corporate feel. And so he asked me if I wanted to come work for him in a small company, and the rest is history.
Good. So Chad knows how to kick?
Yep, he kicked at
So if he was
BC
the
and
coach,
Fresno
then-
State. Yep.
Okay. So you're Bakersfield boy,
Yes, sir.
but then you went Big Blue.
Central Michigan.
Oh, okay.
Chippewa.
So you went
Yes,
to
sir.
Michigan. Okay. All right. So you're still in Michigan.
Yes, sir.
So you're not, but do you despise Big Blue?
No, whatever.
Yeah, cool. All right. Because I was going to say, if you were
know.
like, yeah, Big Blue all the way, we got Wisconsin people in here. Not myself. but I
Yeah.
was just going to say we can deal with that later on. But anyway, all right. So you're with Hathaway, and you've got a pretty important gig there. So let's talk about what you're going to be showing the kids today.
Okay, yeah, what I brought today is I wanted to go through just some basics of math and how it's used every day in the oil fields. So what we're going to go through today is well testing. And what I mean by well testing is checking what a well makes, how much oil, how much water, how much gas. So first here we have a basic diagram of a simple formation, and if you see the red here that means there's a confining layer that is holding the oil and the water and the gas underneath the earth. And what you do is you have a well that penetrates down into the formation that has gas, oil, and water. And then as that well pumps, the oil, the gas, and the water all come up to surface through what is called the tubing and the wellbore.
Now, before you keep going, because a lot of students are going to see wells like that. So is that a sucker pump?
Yeah, this is a rod pump, yes, correct.
Okay.
Yep, they're all over Kern County, and in Kern County, they're everywhere from 500 foot deep to 10,000, 15,000 feet deep.
And is there somebody at Hathaway that determines how deep you guys have to go and testing that stuff first?
Yes, usually that's the work of a geologist.
Okay.
So that's what geologists do, is they determine where the oil is, where we want to drill to, where we want to put the holes in the ground.
All right.
So as a well is producing, one of the most important things is you want to know how much oil the well is making. So what you do is you have what's called a ball trap or a test trap, and this picture here on the right is the picture of a test trap hooked up to a well. And the way that test trap works is all of the oil, water, and gas flow into that trap. The gas is what is lighter, so the gas rises to the top, and then the gas will be then released back in through a gas system, and the oil and the water will fall to the bottom, and the oil and the water will then be metered. So then as I go to the next slide, you see here, this is an example of the meter. So as the oil and the water flow through the line, there's a meter that spins and will give you a reading. And there we get into how you test the well. So I put in an example. So to test the well, what you look at is your gross flow. So you look at what does this meter start at, what is the stop time, and then what, so the meter start, the meter stop, and then what time did you start and what time did you stop. So I'll go through the first example. The first example is my meter. I start my meter, it's at 0 barrels. The BBL means barrels. And then I'm starting this test on this well at 2 p.m. And then my meter stop is at 4 p.m. and I have 13.5 barrels that have passed through this meter. And so as I go through this, everything is always done in what is called a 24-hour gross. So we know what is production for one full day. So if I take that math formula, I'm going to say the meter had a change of 13.5 minus 0, which is 13.5 barrels. And then over the span, if I do 2 divided by 24, because there are 2 hours, 2-hour-long test in a 24-hour day, gives me 13.5 times 12, which gives me a rate of 162 barrels per day.
And that's if it's continuously flowing, though, correct?
Correct. That is if the well is continuously flowing. So if you have a well that starts and stops all throughout the day, then you will extend the time period of that test.
Okay.
So if a well is turning on and off often, then you will usually do that test for the full 24 hours or 25 or 26 hours to make sure you capture all that time.
So what would be an instance where it would have to go longer than that?
Longer than?
The 24 hours. So what would happen, like what would cause that to have to go longer?
Normally what would cause the longer than 24-hour test would be if you have something new happening to a well, if it's a new drill, or if a well has had a new zone or something opened up to it, or if it's responding to what's a water flood or a steam flood, some sort of external force. And so then that well's gross is constantly changing. So then you would want to be testing it more than 24 hours or testing it frequently, test it for 24 hours and then take a break and then come back a few days later and test again.
Okay.
Correct. So the second example, same formula, just the numbers get a little bit more complicated as you change in different times, because as what is called a lease operator, who's a person who does these testing, as their day goes, they don't exactly time up when they're going to check their meters, because at any given time, the person who's doing this is testing multiple wells, they're checking multiple facilities throughout their day. So in this example, we have a meter that has a start date of 13,453.2 barrels at 7 p.m., so at the end of the day, and then they come back the next morning at 4:15 in the morning, or someone else comes back the next morning and they have a meter stop of 16,738.1 barrels. So then same math, the first thing we check is what is the difference in the meter change, which is 3,284.8 barrels. And then now the great example on the fractions that you guys had on the show, this works out perfectly. You take the time, you have 9.25 because it was 9 hours and 15 minutes, so that's a quarter of an hour divided by 24 hours, gives you end result of 1,264.6 barrels per day.
All right, so quite a bit more production than the other one.
Yeah, correct. And so then the next step is now we have calculated what the total flow of that well is. So now we want to specifically focus on how much oil and how much water. So from that well, you will grab a sample of that fluid. There's a continuous sample or a same sample, and you will take that sample and you will heat it up and let the oil and the water separate. From the oil and the water separating, you will then go and measure how much is oil and how much water to get a cut. So for this example, I have 100 milliliters in this of water and 550 milliliters of oil if I'm using this as my oil level point, which normally you look down on top and you'll be able to see and get rid of this inference. And with that being said, then I do a 100 divided by 550 gives me the 18.2%, which is my water cut. And then if you take the inverse of that to make it a whole, 1 minus 18.2 gives you a 81.8% oil cut.
I'm glad you mentioned that as far as looking down at the top and then taking those measurements, because a lot of times when you have liquid in a container, it's kind of just a little bit of that little slope on that edges right there because of the adherence to the container itself. So that is important to take.
And then in the San Joaquin Valley, we have a lot of heavy crude, so this is a very common thing of where the oil is going to get stuck and it's going to be heavier and be harder to read. So it's very important that you're looking down at the top and seeing exactly where that.
All right.
And then the final step of you test this well, you figure out how much oil it makes. You want to know, well, you have to test that accuracy of that well. So in this example I have here, so I have 4 wells, and these 4 wells go to one specific facility. So in that well, we test all 4 of these wells. You can see here, you have well 1, 2, 3, 4, and each of them have their calculated test. BOD is barrels of oil per day. So each one is their barrels of oil per day. They all go in and they run into what is called a wash tank, where the oil and the water are separated. The oil then goes to get sold. The water then goes back to injection. So in the course of one whole month, I look and I say from this particular facility, I sold 1,176 barrels of oil, right? And I also look at how much oil was in this tank at the beginning of the month and the end of the month. And so in the course of 1 month, we went from 70 barrels to 78 barrels, which gives us a difference of we left 8 barrels behind. That means in the course of a month, these 4 wells, 1,176 plus 8 gives you 1,184 barrels of oil sold, which gives us 38 barrels of oil per day if you take 1,184 divided by 30. Right? So now, if I look back, I have our well tests, which gives us 39.6 barrels of oil per day. So I need to check what our well testing accuracy is. And so simply by looking at the 39.6 into the 38 gives you a 96% testing accuracy.
And is that kind of where you are usually, or is there a minimum you guys got to make sure in order to keep those wells going?
Correct. So the biggest thing is you look at the individual economics of every well. But when you do those well tests, you need to say, does the well test that was calculated match the oil that's been sold, right? So you want to look at your well testing accuracy. So that operator constantly wants to see that, ensure the industry standard is that I'm a 95% accurate. So I know that when that 13.2 barrels a day for well number 1, that it is accurate because it matches the oil that's been sold.
And I know you've got a little bit about Kepler coming up on your last slide, right?
Oh, yeah, yep. And then I get to my last slide. So having a degree in math, I put my very last slide. So my favorite mathematician is Johannes Kepler. He is famous for his 3 laws of planetary motion, which were instrumental in understanding the universe we live in, and space travel, and a lot of mathematics and geometry. And it is extremely impressive that someone who is living in the 15th century was able to look through a telescope and determine that our Earth is not traveling in a circle, it's traveling in an ellipse, and there's 2 foci in between the sun and another foci point that exists. It's pretty mind-blowing to see.
Right, especially back then.
Yeah, correct. Where there's no power, Columbus hasn't sailed across the ocean, and he just looks up in the sky and figures it out.
All right. Well, you know what? We certainly do appreciate your time coming in to visit us here on Do the Math. And when you see Chad next time, what I want you to do is let him know that you were a guest on Do the Math with the new set in place. All right.
Okay.
This is our 23rd season. And for coming in, we'd like to give you one of the pins, and make sure you wear that. You wear it prominently so when Chad sees it, he's like, hey, dude, where you get that right there? All right.
Will do.
All right. Curtis, thank you for coming
very
in
much.
once again. And we'll be back with more right after this. right, in studio with us, we have 4th grade student Shourya from Reagan Elementary. Have you ever gone through a winter with snow and ice and cold temperatures yet?
No.
Okay, because I was going to say, I mean, how long have you been at Reagan Elementary?
5 years.
Okay, so you've been all of your schooling at Reagan Elementary. So
Yes.
more than likely, I mean, are you from Bakersfield? You lived in Bakersfield your entire life?
Yes.
All right. Well, perhaps at some point in the future, you'll have an opportunity to endure a nice cold winter sometime.
Yes.
Do you think you would like to do that?
Maybe.
Yeah, why not, right? Try it once, see how it is, right? You ready to do some more math?
Yeah.
Are you able to add quickly?
I guess.
Are you able to add correctly?
Yep.
Yeah, that's the one I can see. All right, head on over to the board. All right, so you and Cece are going to work on this problem together. Cece, go over maximize the sum and what
All
you and
right.
Shourya have to do.
So it says maximize the sum. Circle 5 numbers from the grid below, well, off to the side, such that their sum is maximized. So what does that mean to maximize?
At like the most.
Yeah, make it as big as possible, right? Okay. No two numbers may be selected from the same row or column. Okay, but can they be the same number?
Yes.
Okay, they can be the same number, they just can't be in the same row, same column. Okay, so.
Can't be like these.
Right, right, exactly. That sounds great. Okay, so you think you're ready to do this? We need to circle 5. We need to find the 5 numbers.
They're like greatest in their column.
Greatest, we want to be able to maximize the sum. So if we take these 5 numbers and we add them up, it's going to be the biggest we can make, as long as no numbers, 2 numbers, may be selected from the same row or column that are the same. Okay, so how do you want to start this? What's your strategy?
Maybe top to bottom.
Okay, all right. So top to bottom like highest numbers or top to bottom like top row?
Yeah.
Okay, so you want to look in the top row?
My first instinct is to go with 14.
So we want to. So I'm going to do that one
the
for you.
biggest
How's that?
number for the row.
We'll go ahead and we'll circle 14 here. Okay, go ahead. What else we got?
Then I'd probably go 15.
Okay.
But there's a 13 down in that row.
That's true. There is a 13 down in that
So
row.
I'm going to go with the 12.
Okay, so make sure you scan the whole square though. You're really sure that's what you want? I mean, I'm not going to sway you. You're good with it? You're going to go with the 12?
Yeah, I think
Okay, you go with the 12. Okay, so then what's next? What do you want to do next? What are you thinking? What are you thinking? No 2 numbers may be selected from the same row or column. So when I look at this 12, this is why I'm saying this 12, I'm going to come back to this 12. But if we're starting to look at this row, what are you going to pick in this row?
Well, there's an 11 here.
Okay, so you want to pick the 11?
But there's a bigger number, 13.
There is a bigger number there. That's okay. So do you want to skip over the 11 for this 13 instead?
Yes.
Okay. Okay. So you've picked this 13, but now then this row, that wasn't the biggest one because you could have picked that 15, right?
Yeah, but either way I could.
So either way, so you like this 12 instead of the 15 down here?
Yeah.
Yeah? Okay. All right. I'm not going to tell you no. Let's look at these these 2 rows then. What are we going to do?
So here, the biggest number here is 12.
Mm-hmm.
But
We
I
already
can't
picked
use
the
12.
13, yeah.
So the next biggest number is 9.
Okay. So you want to pick the 9? Or do you want to, because we've got this column here,
Yeah.
and we've got this column here. So if I'm looking at this column here, what do you want to pick in this column?
Probably the 13.
Probably the 13? Okay, we can do that. Okay, so that leaves us this row and this column, so our last one we have to pick is the 8, right?
Yeah.
Are we okay with the 8?
Sure.
Okay, so we need to figure out if that's really big. Are we happy with this? Are you going to add that up really quickly and see what that adds to?
14, 12, and 8.
Okay.
60.
60. So
Yeah.
you're pretty sure that that's as big as we're going to get?
Yeah.
So 60 is pretty good, but there's a way to get 64.
So we want to try again?
64.
Yeah.
So
Okay.
I'm
so
going to
we're
give
gonna
you a
go-
hint.
Well, hold
So,
on.
Yeah, erase those numbers, and I'm going to give you a hint. All right? So you started with the 14, and the 14 was a good one. So I'm going to say stick with the 14.
Okay.
Now, what I would suggest is the biggest number on there is what?
15.
Take both of them.
Both?
Both.
Because they're different columns and different
Now, you need to
rows.
figure out the last two numbers.
So what do you want to do here? Because we've got it, so our only things we're working with are these right here. So we're stuck right here. Because we've got those rows and those columns. So what do you think you want to pick out of these four to make this work?
Oh, I got it. It's 11 and 9.
You didn't want to do 8 and 8?
No,
11 and 9's bigger?
because it's 20 versus 16.
I like it. Okay, so here, that adds up to 20.
And there, 15 and 15 is 30, plus the 14 is 44.
So we've got 30 and 20, that gives us the 50,
Yeah?
plus our 14, and that gives us our
64.
64.
There you go. Nicely done. So a lot of times those problems where you got 60, and a lot of times students will go, all right, I got 60, I'm done. I found the maximum sum. But then they wouldn't have the maximum, would they?
Yeah.
Right? Because what you need to do is try it a couple of times to see if it actually is the correct answer of 60. And I always suggest take the biggest numbers and then work down from there, because then that way you know you've got the biggest possibilities already out of the way. Sound good? Yeah. That's another strategy for you to use on some different mathematics as you continue on. We'll be back with more right after this.
Welcome to Cal Poly, a distinctive, world-renowned university located in San Luis Obispo, California, and founded on one principle: learn by doing. For more than a century, we have proven that the most effective way for students like me to learn and grow is to jump right in, head first, and hands-on. And while we're known nationally for our engineering, agriculture, and architecture programs, learn by doing experiences mean that our students excel in every discipline and every one of our 6 colleges. Mustangs are uniquely positioned with the skills to shape the future of California, and when you help shape California, you change the world. It's one of the reasons we've been named Best in the West for 30 years and most innovative school in the West among public master's universities. It's why this year, we're able to recruit our most academically accomplished, most diverse incoming class ever. From our first days on campus, every student engages in an all-encompassing learn-by-doing culture that you just can't find anywhere else. From co-authoring peer-reviewed, faculty-led research to pursuing passion projects that connect their areas of study to real-world needs. Selena's son chose Cal Poly not just for the computer science program, but for the chance to build something new. Selena founded Slow Hacks to challenge students of all skill levels to use hardware, software, and code to build creative products in one weekend.
I think that hackathons are pretty much an essence of learn by doing. At a hackathon, you spend 12 to 36 hours building a project, which is pretty much what learn by doing is.
Thanks to Selena's leadership, Slow Hacks connects hundreds of students each year and serves as a recruiting event for tech employers.
As for Slow Hacks, I really hope that it remains as a prominent hackathon organization within California, and that it's able to positively affect a lot of students around California and around the world.
Real projects with real consequences and real risk of failure. Any Mustang will tell you that is when you earn experience you'll never forget. Zoe Fox was among a team of architecture students who worked with residents of Paradise, California in the wake of the Camp Fire to envision a more resilient community.
This project is learning through service. It's kind of like an emotional investment in your work.
Mustang spent months immersed in resilient design with Professor Stacy White.
Working with a real client is a completely different experience than anything you get from really any other studio. You have to get into the details, like how can this be a real building that can be built and service real people?
On the final trip to Paradise, the teams presented their designs to a community determined to rebuild.
In reflection, I think we're all insanely proud. We've all developed this attachment to the people, to the community, to the project, and finishing is giving them this gift of design, which is the only thing that we can possibly do as architecture students to help this community that's gone through devastation.
Years of learn by doing means that graduates are ready day one to take their future into their own hands, ready to shape their careers, their communities, and California for the better. For NASA astronaut Victor Glover, he took his learn by doing attitude to the International Space Station. While in orbit, he relayed a special message to his fellow graduates.
I want to encourage you to continue to learn by doing. That doesn't stop after you graduate. It sure hasn't for me.
Glover is the latest in a legacy of Cal Poly astronauts. He piloted the SpaceX Crew Dragon and completed 3 spacewalks during his historic mission. Next, Victor could be headed to the moon through NASA's Artemis program.
I want to encourage you to dream big and to be patient and enjoy the journey.
You're now a graduate and member of the Cal Poly Mustang family. Congratulations!
So long for now. Keep shining. Graduates, from up here, your futures look very bright. I expect to see big things from this graduating class. Ride high, Mustangs.
He is one of thousands of Mustangs answering the call, going where California needs them, living a life of learn by doing.
And there's a lot of students in Kern County, I'm sure, have made that trip over to Cal Poly to check out the beautiful campus that's over there. 636-4357 is the phone number. We do have phone tutors available Tuesdays and Wednesdays throughout most of the school year. Shourya, a 4th grade student from Reagan Elementary, loving 4th grade.
Yes.
Do you do anything other than just go to school in 4th grade? Are you involved in any activities yet? Because I know once you hit 4th, 5th, and 6th grade, you can do things like chorus or after-school sports or things like that.
No.
Not yet?
Not yet.
Okay, do you look forward to doing any of that? Because I think, don't you have to be in 5th grade to do band and stuff like that?
5th and 6th.
Okay, so are you looking forward to anything like that?
Yes.
Such as?
Violin.
Oh, good. Do you play already?
No.
Oh, okay. So you're going to start next year?
Yeah.
You be ready in the middle of next year, come back, do a little solo for us?
I don't know.
Well,
we'll check.
he already does do a musical instrument, though. He was talking about that earlier.
What have you got?
Electric guitar.
Oh, you're a guitarist. And you're going to be a violinist. How about a trumpeter?
I don't know.
All right, yeah, that's a totally different thing. All right, you ready to do some more problems?
Sure.
All right, head on over to the board, because I remember earlier you said that you were feeling pretty good about the order of operations.
Yes.
So you and Cece are going to come up with a problem, and you're going to help her because you're going to give her some numbers.
Yeah.
And then you guys are going to do that problem, but you're going to have to explain to Cece how the order of operations work.
Okay.
All right.
Are you ready?
Yeah.
Okay, we've already covered the exponents.
Yeah.
How about like
Parentheses.
brackets and parentheses and all that? You good with those?
Yeah.
Okay, so if I start putting a whole bunch of them up there, you're okay?
Yeah.
Okay, good. All right. Okay, give me a number. Small.
11.
Okay, let's do, you know what, I'm gonna go throw a bracket in there and then a set of parentheses. All right, give me another number.
16.
Okay. Let's see. Give me another number.
What?
Give me another number.
27.
27. Okay. We're gonna do that, and then how about give me another number.
4.
Okay. And then we're gonna throw an exponent on there somewhere. Let's do it.
Or you just throw
right
it on the 4.
here. Yeah, we'll do
There
that.
you
We'll do that one.
Okay.
I'm starting to feel a little bit nervous about that 3. Let's go ahead and we'll just go ahead and do it.
Squared.
Yeah, we'll do it. Okay. How's that? You ready?
Sure.
Okay. There you go. Take it away.
Okay, so we're going to start by doing the brackets, or parentheses.
Okay, well, the brackets or the parentheses?
Yeah.
Which one? You've got to decide.
Well, this one,
Why?
left to right.
Left to right, absolutely. Just the way we read, we want to go ahead and go inside our brackets, and we're going to do those parentheses first. Okay, I like
So
it.
16 minus 5 is 11.
Nice.
And 27 divided by 3 is 9.
Okay.
Then we have to add those up, which equals 20.
Okay, so you've got some stuff going on there. Are we going to rewrite some of this at some point, maybe?
Yeah.
Okay, go ahead.
So I'll put these in brackets.
I like that because you did all of that inside the brackets.
11 plus 8. Okay, so now we have minus 4 squared.
Okay.
4 squared is basically another way of just saying 4 times 4,
Good.
which is 16.
Nice.
So it would be minus 16.
Okay.
Now we have to do multiplication and division,
Okay.
but there is none.
There's none? Are you very sure? I see a multiplication somewhere. Where do I see a multiplication? So let's look at our problem. We've got 11 plus 8, 20. 8, 20 brackets. What does that mean?
160.
Okay, because this means a multiplication,
Yeah.
right? Okay,
Yeah.
good. All right.
So 11 plus 160
Oh, yeah, don't put your...
Whoops.
Yep, there you go. Go ahead and yep.
plus 160 minus 16.
Okay.
Next, we're going to do addition and subtraction, but since it's both, we're going to do left to right.
Okay, perfect. Now let's pause really quickly because I want you to say that one more time. We're going to do addition and subtraction.
Left to right.
I love it. Thank you very much. We're doing it at the same
So-
time, but we're starting it from the left, and we get...
So 11 plus 160 is 171.
Okay.
With minus 16 is 155
Fabulous job. I like it. So that equals...
to 155.
Just put up one. Fantastic. Nice.
There you go. So you do know the order of operations.
Yeah.
Well done. Come on over here, young man. So when you say the order of operations, there's a little acronym, a little saying that people say with it. Do you remember what that is?
PEMDAS.
And what does that mean?
Parentheses, exponents, multiplication, division, addition, subtraction.
Nicely done. Have you ever heard of GERMDAS?
No.
Okay, because parentheses is what we all grew up with, and a lot of people know that. But there's other ways to group numbers.
Bordas.
Grouping, right? Because there's other ways to group numbers besides parentheses, like you did today with the brackets, right? Also, absolute value is a way to group numbers. Have you done that yet?
No.
Bonus for you coming up soon, son. But there's other ways to group it, right? And then we have add, subtract, those are opposites, right?
Yeah.
Multiply, divide, those are opposites.
Yeah.
Exponents, you need an opposite, right? So instead of raising something to the second power, you
would
can
be
take
roots.
the square root of something, all right? Did you know that you're now an ambassador for Do the Math?
No.
Do you know what that means?
No.
You have to let other people know about Do the Math. Can you do that?
Yeah.
That's easy enough job, right?
Yeah.
Have you ever seen one of these?
Yeah.
What is it?
A Rubik's Cube.
It's a Do the Math Rubik's Cube. So I want you to take a minute, see if you can get the Do the Math or any side all together.
You any good at those?
Have you done Rubik's Cubes before?
I've done it. I've just forgotten it.
Well, you go ahead and try it out right now. And if you need some help, I'm sure Cece, she's a master of Rubik's Cube. She can help you out with that because I know I'm not going to be able to help you out with this.
Yeah.
And Cece looks very confident that
I
she can
am
help you out with that
crazy
as well.
confident.
So while you guys are working on that, I'm going to come over here and talk to you guys about something that's coming up. This is happening with the Bakersfield Police Department. It's happening on October 24th. So from 4 to 8 p.m., Halloween, all right, is going to be happening with BPD. So what you can do is going to be downtown and just go online. And if you look up Halloween, so I have not been to one of these yet, and I can only imagine what it's going to be, but I'm sure that it's going to be a lot of fun. And it's coming up on October 24th, and something so that the kids can go out and relate with the BPD, and I'm sure that's part of what they want to do this for. Halloween, and I am saying that correctly with law, not law, or whatever some other people are saying like that. So anyway, that's coming up on October 24th. And that is tomorrow night, because today's Donnie Day. It's the 23rd of the month, and we know on Do the Math Donnie Day because Don Mattingly was 23, and this is our 23rd season of Do the Math, so we all love the number 23 right here. We're going to come back over here, and we're going to check out Shourya and see how he's doing. And you've got 2 of the 3 rows, and you've almost got that top row done right there. You feeling pretty good with that?
I guess.
Yeah, keep on going. So when you're, what kinds of things are you thinking about as you're doing that type of a problem? Because that is a math problem right there.
Oh, it is?
It is.
Oh.
So how do you think you're going to get that top row all done?
Oh, this part?
Yeah.
I'm thinking to, like, get these 2 white spaces down to here.
Right. Okay. So go ahead. You keep, because you've done pretty well so far, and I've only given you like a minute to do it. So there was on the news the other day. There is a tiny Rubik's cube. It is, I think it's like 5 millimeters big. Thing's $5,000, and it might break. Hey, did you learn a little something today?
Curious why.
What?
Did you learn a little something today?
Yeah.
Did you have fun today?
Yeah.
Excellent. That's exactly what we wanted to hear. Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, Edison International, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.